Welcome to Maths and Science by IITian channel. In present lecture, I will be taking up an important topic in JEE and NEET physics, that is discussing the thermodynamics. Under thermodynamics, discussing the chapter thermal properties of matter. Thermodynamics is a very big science in which thermal sciences it is called as, in which thermodynamics, thermostatics, thermal properties and usage of the different materials for thermal purposes are discussed. And thermal properties of matter is one of the topics in thermodynamics. Until and unless you know thermal properties of the matter, you cannot understand the thermodynamics. It is the dynamics of the thermal matter involving thermo. What is thermo? Thermo is the heat energy. And if you appreciate the uses of the understanding of thermodynamics in our day-to-day life, then you will better understand why these properties of matter are to be studied in respect of the thermal properties. Why thermal properties are different and why they should be studied separately. We already have MLT, mass, length and time, but still we are required to study thermal properties. What are its uses and why thermodynamics is vital in any engineering application. You might have seen you are using the electricity every day. From where electricity is coming? Electricity is a form of energy. It is coming from thermal plants, power plants, and electricity is being distributed to us, to customers, consumers, industries, domestic customers, domestic consumers, through generation of electricity in thermal power plants, nuclear power plants, and what are the different equipments and how they are used. I will just give a brief. It may not be a very lengthy introduction, so that you will understand how this works, electricity generation. It will be useful even in your electricity and magnetism, and also in your electrical technology. And the production of electricity, it requires certain processes, because we produce the electricity from fossil fuels. They are petrol, diesel, kerosene, aviation turbine fuel for aircrafts, and we are producing electricity from coal, peat, lignite. We are producing electricity from nuclear technology, nuclear engineering, nuclear power plants, which use uranium and thorium. That means how we are converting that particular nuclear atomic energy into electricity, so that we are consuming today. How coal is getting converted to electrical energy. How this steam is getting converted to electrical energy. If you have that particular idea, small brief and particular idea about usage of electricity, then you will understand everything is thermodynamics. All these things are thermodynamics. That means heat is converted. We are converting fossil fuels, chemical energy into heat. We are converting nuclear energy into heat, and that heat is converted to, through generators, we are converting heat to electricity, and we are using that electricity on day-to-day basis. What are the different components we usually use? A heat exchanger or a boiler if it is a steam, or heat generator, and we use a pump or a condenser. We use a pump, we use a compressor or a condenser, and we use either steam turbine or gas turbine. Now, we will dwell into the thermodynamics basics, then we go into the thermal properties and we try to understand them. Let us take a simple steam turbine. Let us take a simple steam turbine. What does a steam turbine consist? It consists of a turbine, as the name suggests. And this whatever cycles we are operating are, the highest efficiency cycle is Carnot cycle. Carnot cycle. There are many cycles which we use for generation of electricity. Carnot cycle, generation of energy, rather I can say, shaft work. Shaft work means converting heat energy into the shaft work. It is a turbine. There is a shaft connected to it. The real turbine may be very big, but I am just giving a schematic. The shaft is rotating. What rotating shaft does? If you go through your electricity and magnetism chapter, you will understand that there are generators, power generators, electricity generators. How they work? They are based on the rotation, speed of rotation, RPM, power generators, working at 1500 RPM, 1200 RPM. This is the shaft work. Power generators produce the power from shaft work. This is the shaft work. From where this shaft work is coming? It is coming out of the turbine. This is the turbine. For the turbine to do the shaft work, there should be a process, and there should be a working fluid. In a steam turbine, what is a working fluid? Working fluid is equal to water. This is working fluid. And what it is happening, you just see. It is a horizontal trapezium having a narrow entrance. At the entrance and at the exit it is becoming large. The exit is large diameter exit, small diameter entry. That means there is what is the process called expansion taking place. There is an expansion taking place. Your working fluid is going inside the turbine and there is an expansion of the working fluid. What happens due to this expansion? Adiabatic expansion isothermal expansion, different processes of expansions are there. That we will be discussing further. Here we are confining ourselves to understand the basics of a steam turbine plus steam power plant with steam turbine. This is what we will be discussing. Just few minutes only. Afterwards, we will go into the real subject of thermal properties. How thermal properties play a very important role. Now, what is happening in the entry? In the entry, there is either a boiler or a heat exchanger. Fuel is fed in the furnace. Fuel is fed to the boiler. Fuel combustion takes place and the working fluid, whatever water is there, it is heated. You might have seen in your domestic boilers, there will be coils, and through coils some coal is put around the coils and coal is burnt and the coils will become hot, and through coils water passes through. Water gets heated. That's one type of. Another type, coal is put in the, I will just show, it is domestic boilers. If you see in your home, you can ask your parents also. This is a type of boiler regularly being used. This is the coal tube or pipe through which coal is put and coal is burnt here. And water is present in this boiler. Water and coal will not be mixed. Coal will be through a separate pipe is fed into the boiler pipe. We can even call it as a stack. It is only a schematic, and coal is burnt and this pipe gets heated and the water surrounding it gets heated, and there will be a small exit here, valve, so that hot water is collected. This is the domestic boiler's functioning. Now, it is an industrial boiler. The fuel combustion principle is same and water gets heated here. Now, to boiler, water is coming from pumped through a pump. A pump is used to pump the water. This is one process. Next, to pump, water will be coming from condenser. You may be knowing the process of condensation. the temperature is reduced. Turbine, high temperature. Water goes inside the turbine, it gets expanded and it gets cooled. Arrow should be this way. And it will not get cooled to that extent that you can use it. Still it will have a high temperature. From there it goes to the condenser. Heat is rejected here. Heat is rejected. And the working fluid gets cooled. And that working fluid will get pumped to boiler at a low temperature, and boiler heats the steam working fluid and it sends. The temperature at the entry of the turbine and exit of the turbine, this is high temperature H and high temperature low. Temperature will be high only, will not be very atmospheric temperature, but it goes to the condenser. Heat is rejected there. And there are how many processes? Here heat is, by the process of combustion, heat is in. Heat is taken in the system. Heat is rejected from the system. And this 100% of heat cannot be converted to work. Some amount of heat is converted to shaft work. Shaft is made to rotate and power is generated. This generated power is distributed to customers through commercial electricity department, BESCOM, MESCOM, like that, commercial establishments. They distribute this power to different customers, consumers. This is the requirement. This is a simple plant I have shown so that you can appreciate the importance of thermodynamics. We get the power like this. This is the electrical engineering behind thermodynamics. Now, one by one we will appreciate the parameters or properties of the matter. There is a working fluid. Here we have taken the example of a working fluid of water. The working fluid can be air also, because we know that in fluid mechanics, air can also be a working fluid. Water can be a working fluid. Everything is a fluid under certain assumptions and certain pressure and temperature conditions. Depending upon the working fluid, if it is water, then it is a steam turbine. Then there can be gas turbines. And this particular cycle is initially made by Carnot. Actually, what is the cycle? Just without going into the Carnot cycle, what is the cycle we are talking about? One is heating the working fluid. Simple way we are writing. We are not complicating the things. Here we are expanding, expansion, From there, we are condensing or compressing. Compression. Then it goes to pump, and from pump it goes to again to the heat exchanger or a boiler or whatever equipment you use for heating the working fluid. This is the process. This is like a cycle. And in this cycle, if I use different types of materials, matter, working fluid, which are the parameters I require? They are the thermal properties of matter. First we will take heat in. Here heat out. Here soft work, that means power generation. Here it is pump. Now we will take up the heat in. Just for your brainstorming, let us take one heat in is there, a process of heating the working fluid. These things I am explaining on my own so that you will understand and appreciate and understand the concepts well. These things are not taken from any book. The notes is made on my own experience. Heating is there. If you have any doubt in understanding these, please try to comment, and if you like this video, please try to hype it and subscribe to my channel. Now here heating is there. What you are heating? You are heating the working fluid. Then let us try to study working fluid. What are the parameters I have to study as far as working fluid is concerned? When I am heating something, I want to know the initial temperature and final temperature. That means initial and final temperatures, which I am supposed to know. Second, how much I am heating? Am I heating 1 lakh liters of water, or 1 lakh tons of some fluid, or 1 ton, or 2 tons? Quantity, flow rate, that particular 1 ton, because it is fluid is moving in the cycle. What is the amount of fluid? I require fluid flow rate. That means I require working fluid flow rate. Do you agree? These are all going through the intuition only. The flow rate of a fluid can be volumetric flow rate, it can be gravimetric, or mass flow rate. What is volumetric flow rate? Volumetric flow rate is equal to liters per second or cubic meter per second or cubic meter per hour. This is the volumetric. This can be expressed in any way, the way you want. Liter is volume, cubic meter is volume, and you should know the differences between cubic meter and liter. Water at normal temperature, for water 1 liter is equal to 1 kg mass. Liters per second, cubic meter per second. What is the relation between liter and cubic meter? 1 cubic meter is equal to 1000 liters. That is equal to, it can be called as 1 kiloliter. Please remember this. We measure it in SI units and cubic meter per second. Now, this is a measurement of the volumetric flow rate. What is mass flow rate? You have been given the working fluid as water and volumetric flow rate is given. Then this is practically denoted as dV by dt or V dot. Flow in volume per unit time, V dot. And mass flow rate, mass is in kg, it should be kg per second or ton per hour, metric ton, or kg per hour. Like this we can measure. Then you have been given the volume. Then how to convert into mass? Mass flow rate is represented by m dot, that is equal to dm by dt, that is measured in kg per second in SI units, and this is nothing but rho. This is the density, rho into V dot. Volumetric flow rate into rho. What is rho? Rho density is equal to kg per cubic meter. You should know this. Density of a fluid. Then it will be kg per cubic meter into cubic meter per second. That will be kg per second. If it is volumetric, it is cubic meter per second, V dot. If it is mass flow rate, then we will measure it in the kg per second. That is nothing but rho into V dot. What is the density of water? Under normal conditions, we take density of water as 1000. Kg per cubic meter. Therefore, m dot is equal to 1000 into V dot. Now, what is the property we require till now? Temperatures we require and mass flow rates we require. We have understood how to get them. Now, what more? In the context of thermodynamics, I know the mass flow rate, I know the temperature, then I want to know the heat input. Third is heat input. If you see the diagram, it will be like this. Heating process, some heat is input, heat input. Whatever is heat is given to the mass of the fluid, whatever heat is given to the mass of the fluid, that fluid gains that heat. There may be certain losses. We are not talking about the losses here, practical losses in the operation. We will not be taking up because the subject will be complicated. Now we will confine ourselves to understand the thermal properties, why they are required and what are the thermal properties we have to study. Because studying thermal properties like by hearting the things or listing the things is not going to help you until and unless you understand the basic science behind them. Why it is happening like this? If you understand the process, then you will easily understand the thermal properties well and you will apply them in the day-to-day applications. Now, we have seen temperature is required and another mass flow rate is required. That means measurement of the mass is required, measurement of temperature is required. Next, when something is happening like this, we are giving some heat input to the mass, then what is that heat? How we calculate that heat? There comes the question, what is heat? Heat is a form of energy. How heat is measured? Heat is a form of energy measured in joules. Just compare it with work. Work is also a form of energy measured in joules. But one principle is here which we are going to prove it in thermodynamics as we move on. Remember, one thing is that work can produce the heat, but 100% of heat cannot be converted 100% to work. Heat cannot be converted fully 100% to work. Both are energies only, but we cannot convert 100% of heat to work. Now, why this particular restriction is there? What are the constraints in the cycles? When we go along in studying thermodynamics, now we will move to the other definitions. These are all about the thermal properties. Why thermal properties? These are to be studied, I have given in the introduction by showing a cycle of operations in a power plant, ultimately generating power. Now, there is one process, heating, we are discussing now. There is one heat in. We are inducting some heat into the working fluid. We know initial temperature, final temperature from the measurements. How to do the measurement of temperature, I will explain as we move on. Let me first finalize what are the properties that are to be essentially to be studied in thermodynamics. Some of the important properties, we may not be able to study all the properties, at least some of the important properties, and what are their meanings, how they are to be measured, we will be taking up in the following lectures. Here what are required to be studied, we are understanding why they are required. The working fluid is heated by burning the coal or wood, biomass or coal, and working fluid is heated, that is water is heated. WF means working fluid, it is heated. For studying what is the heat we have given or what is the heat gained by the working fluid, you are giving by burning the coal, you are giving heat to working fluid is also gaining that heat. That means it is absorbing that heat. That heat absorption by the working fluid is controlled by the initial temperature. For example, water is at a temperature of 25 initially. The water is boiled to 100 degrees centigrade or it is gone up to 90 degrees centigrade. That initial and final temperatures are known to you in the domestic boiler. And you know how much coal or how much wood you are using, that is mass. Mass of fuel. And if m dot m is mass in kg, m dot is mass flow rate in kg per second or per hour or per minute. Don't worry, it is mass by time, dm by dt. When some mass of fuel, you have taken 10 kg of coal or 10 kg of wood, you started burning it and water is gaining the temperature. Then what is the heat gained by water? That is the question here. You are burning the wood, you are heating the water. Here burning of wood is taking place or burning of coal is taking place. Combustion, rather I can call it as combustion of the fuel is taking place. And water or fuel getting, let us say fuel getting heated, that is another process. Fuel getting heated is taking place. Now, between these two, how the fuel is absorbing the heat? For example, the fuel is water, it will absorb in a certain manner. If the fuel is some lubricant, it will absorb in a different manner. Fuel is other than water, it absorbs in a different way. How much heat is absorbed by the fuel is the most important. Heat absorbed by fuel is equal to, not fuel, rather it is fluid. Fuel is the what you are using for combustion purpose, fluid, is governed by the equation mcp into delta T. Some constant Cp is used here. What is this constant? Why it is used? What are its properties? Now we will study. I think you are getting interest in finding the different thermal properties that are required for us to understand the thermodynamics. Now, heat is a form of energy, and energy has the units of joule. Let's use the dimensional analysis here. M into Cp into delta T, change in temperature from initial to final, is equal to heat, that is equal to joule. That means here we can even write it as M S delta T is equal to heat, that is equal to joules. Both equations are same. Whether it is S or Cp, S is equal specific heat capacity of the substance, that means that is the working fluid. Now, we will use the dimensional analysis to understand what is Cp or S. This is the equation, please remember. Now, Ms delta T or Mcp delta T is equal to joules, that is equal to heat. Now, what is joule? Joule is nothing but Newton meter. Now, M is equal to in kg, M dot is equal to kg per second, and delta T is in Kelvin. That implies M Cp delta T is equal to joules, implies kg Cp into Kelvin is equal to joules. That implies Cp, specific heat capacity, is equal to joules by kg Kelvin, that is equal to joules into per kg per Kelvin. Please remember this. This can also be written as small s. Specific heat capacity. Specific heat capacity of each fluid will be different. Specific heat, now you define the specific heat. Specific heat is the heat required by the fluid to increase its temperature by 1 Kelvin or 1 degree centigrade of a unit mass of 1 kg. You just see, we are defining it. We have not come from definition to equation, we are going from equation to definition. Cp or S, that is specific heat capacity of a substance or a fluid is equal to quantity of or amount of heat required rise its temperature by 1 degree centigrade per unit mass. You just see. Very, very important property. Till now, what are the properties we have studied? For example, instead of m, if I use mass flow rate, what happens? M dot is equal to m by dm by dt. You agree? Then heat is equal to mcp delta T. That is equal to, that implies, for example, heat rate H dot, always x dot is equal to rate of x. A variable x is taken, x dot, or you can say anything like that matter. A dot is equal to rate of A. It is universal in physics to mention something like this. H dot is equal to heat rate. H dot, how it is measured? When H dot is heat rate, then m should be m dot. That implies H dot is equal to, instead of m, we will be using the m dot Cp delta T. Where m dot is in kg per second in SI units, H dot is equal to joules per second, that is equal to watts. This is power. You just see how we are going near to understanding the thermodynamics principles. Our ultimate aim is to produce the power. Heat rate and power generated both have same units, watts. But heat rate, all heat is not converted to power. For that, there is one cycle defined, systems are defined like Carnot cycle, where we get the maximum output. Beyond Carnot cycle, we cannot get the efficiency. Every thermodynamic cycle will have an efficiency. And till now, what are the things we have studied? I will take up more and more properties in the following classes. Properties is not yet fully completed. I want to close this lecture as of now. We have studied about temperature. We have only understood what is the concept of temperature. We have not yet fully gone for measurements. Only defined temperature. We understood the concept of temperature and mass flow rate, heat generation rate, specific heat capacity of a substance. I think with these 4 definitions, we will close this lecture. In the next class, as a part 2 for the proper thermodynamic properties of the thermal properties of the matter, we will do in part 2. We will complete more properties like specific mass. We will discuss specific weight, enthalpy, entropy and other required parameters, properties that are required to be studied for understanding the thermodynamics. Once we understand the requirements of the properties of the matter, thermal properties of the matter, then we will go for measurement of them and what are the principles governing measuring of these properties. How a specific heat capacity of a substance is measured, how a temperature is measured, what are the temperature scales we employ, and what is the calorie and how calorimeter is used. All these things we will discuss as we move on. Thermodynamics itself is a very vast subject and we are only touching the introductions part now, definitions part now. Measurements part will come next. With this, I want to conclude this lecture. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. If you feel there is a value addition to you because of this lecture, kindly share and subscribe to my channel Maths and Science by IITian and kindly hype my video, this lecture video. Thank you. Best